So we'll get started here. My name is Nate Snapp. I work at Adobe, and I am a Hadoop engineer there that works on our cluster. And I tend to be a makeshift build guy. So here I am to talk about how we do our build and release there. So a little bit about me. I work on a team that comprises of people that are both in India here, in Utah, and we have, and actually, I guess in a lot of different places, we have a number of people that use Hadoop for doing data analytics, reporting numbers on usage of our Adobe products, that do modeling, and we manage all their use of that data in Hadoop. So I came over from an acquisition of a company called Omniture about 6 years ago, and that was a company in the web analytics space that has its own proprietary analytics solution. And about 4 years back, moved over to Hadoop and started working in that space. Something about builds. My history, I've done a lot in systems engineering before the web analytics space, and there's something about an environment that I'm coding in that I just always am trying to optimize, maybe because I tend to find it the most painful thing of all. And so every time that I seem to have entered the build role and subsequently left, I can't quite seem to leave it alone. So here I am again. So to give a little bit of the history, 4 years ago, about 4 to 5 years ago, Adobe was starting with its own significant investment in Hadoop and spinning up a cluster for all of this, at the time, marketing analytics. And we were looking for a way to adequately serve the growing data needs for our data scientists, our business analysts, and there was a team about 6 or 7 developers that were working in this role of building ingests of all the data into this environment. And I came along about 6 months into that, and they were getting all their training on Hadoop. And when I came onto the scene, it was a little bit of a Wild West, kind of anything went. And so I kind of felt maybe like this guy here. So they tell me you fancy yourself a tuba player. And so there I was, you know, feeling a little bit like I've got a certain way of doing things, but maybe my way of doing things appears as interesting as this guy with a tuba. 3 years ago, things were growing very rapidly, and there was a tremendous amount of use coming from that Hadoop cluster. We were actually even doing personalization of products, segmentation of users, a rich understanding of marketing profiles, all in this Hadoop cluster. And so I think for what everyone that was working, our data stewards, our data scientists, they kind of saw this, hey, we were working in Oracle or SQL Server or whatever it was. We've gone from data, now we're working in big data. For the engineers that were maintaining this, it seemed a little bit more like this. As the directors guided the room of banjoists, and they say, "Your room is right here, maestro." Sorry for anybody who likes banjos. So as I looked at what we could do to help tame this, we had by chance been building a lot of code, and Gradle was in a number of places that we were grabbing and pulling from and implementing. So we started using Gradle for our builds, and I'll kind of go over this diagram here. There was a lot of things that came into play depending on the team that was integrating. But Gradle became just another piece of the puzzle that was helping do our Java builds. And so we went with that. It was fine. And this is just a small subset of the technologies, but these are probably the main things that you would have seen 2 to 3 years ago. And a lot of queries from people that are using Hive, a lot of Java, a lot of Python, some R. And anybody here, who here is a Hadoop, works in Hadoop at all? Okay. Yeah, I know you. I've seen you present, yeah. So we had the growth that was happening in this environment, and we realized, okay, we've got something for Java. Hive doesn't really have a story. Everyone's fine with just using the Hue web interface to do that. Some people were trying to get their own tools and JDBC, to plug them in. Python was sort of a free-for-all. R was even more of a free-for-all. So we adapted a few tools where we could, and for Python we use this thing called buildout. That's that little block there. They don't really have a icon or anything. So, and sorry if this sign is falling off here. So we started using buildout, and we had Ant, and on the deploy side, a lot of it was very much silos, and we had teams that would just simply copy files, do rsyncs. Other teams that actually had a tool for maintaining what was going out to the cluster. I'm just going to pull this off here because it's just kind of slowly dying. Okay. All right. So as these teams kind of worked in their different silos, they would come up with very clever, useful ways of bringing data in that usually stem from what they had learned and best practices that they had, but we really weren't combining all of that knowledge into a single way of deploying and managing code in the Hadoop environment. And as a result, and I've heard other people say this who've worked in Hadoop environments, it's you see code that gets released and you can't figure out how it got out there. You can't figure out how to recreate it. You lose things. A bug happens and nobody knows how to get the patch out there with enough confidence that they can really do that. And it's all compounded by the fact that this Hadoop environment is all about data, and so it's very dynamic. The data changes, and all of a sudden something that worked great now has a glaring hole or bug that you have to work with. So we tried to consolidate that and make a tool that would help bring that together. I don't know if that's showing all the way on the screen here. Here, pull it over a little bit. So came up with Adobe Flint, and it was going to be a series of tools to help us consolidate consolidate all that knowledge of how people were deploying, because they all had their own ways of doing it, and not all of it was bad, but it was very much one-off. And so we'd have one team that would build a char, deploy it. They could build that char repeatedly. And it was a great way of doing that, but other teams couldn't take advantage of that because it was built around a very specialized shell script, and it was very customized for what they were doing. So we wanted to get a series of tools for these different technologies. Every time I look at this, I want to pick one of those up and see if it could throw it and get it to stick in the wall or something. So we had some considerations we had to go through, and one of those was we wanted, there's all these nodes in the cluster. Typically, users are working on gateways. It's not always the case. There may be an edge node that is serving something that's more outward-facing and not an internal node. We want to be able to deploy to all those nodes, if need be, whichever ones, and customize that. We wanted to have a generic deployment mechanism that we could all share and rally around, and have that usable no matter which language you were deploying with. We wanted to remove boilerplate code, create runnable tools and scripts. We wanted to figure out kind of on the Python side of things. We weren't having a great love for build out. It worked, but it was hard to find all the documentation, and it was kind of its own beast, and we wanted something that we could think of with all the other tools involved and not spend a whole lot of time on one tool when there was a problem. The problem was if we didn't use that, then we went back to not having reusable code. We had to again just find out one way that was not reusable. We also we had data scientists and analysts that wanted to use Python. And we were thinking, if we can get a tool, we're already having difficulty with engineers using this tool. If we can get something that engineers like, and then lower that barrier for what it takes for them to use it, maybe we can even get some of these advanced or more engineering-minded analysts and data scientists to even adopt and get them using better practices for how they deploy. So that was kind of a desire we had. We also wanted the tool, specifically with Python, we wanted to be able to also have it useful for the admins so they could deploy things as administrators. We wanted to be careful because we knew, especially with build out, user rejection was a real possibility, but the alternatives were much worse. They were going to try and re-implement in their own way, and we wouldn't have any common base to work from. So some of the important decisions, we want to decide on the internal code repo we're going to use, if we're going to use Maven or Ivy, how that was going to be structured. Actually, and on that, especially because we're going to be using other languages, Maven is very Java-centric. And so when we looked at it, Ivy had a number of things that made it feel more flexible to these other languages. So we ended up going with Ivy. We had Jenkins. There was a team using Jenkins, another using Hudson. We wanted to decide how much of the smarts we wanted to put in Jenkins. Did we want to have it do everything? Or did we want to try and, what was that balance going to be? We weren't initially saying, okay, it's all going to be Gradle. Just as part of my background, I used a tool in the past called Scones, and it was used in the system programming world a lot. And I really liked flexible languages that you could kind of build on top of. And I thought, okay, if we can find something like that, and not being a Jenkins expert, not to say that you couldn't do it. I've seen people do amazing things with Jenkins, but I wanted to stay very close to what's programmable and extensible in that manner. For Python, how would we package Python? How would we deploy that? It was kind of easy for the others, is we could just do a zip or a tarball. And then we knew that LinkedIn, they'd been making their own tools, and so they talked about this. So Ethan Hall, how many of you saw the PyGradle talk? Yeah? So we saw Stephen Holzappel's presentation last year, and I'm really excited about that. And Ethan had been continuing to work on that, so we thought, what can we bribe Ethan with to get him to maybe give us some of his ideas on Python? We wanted to know, are we going to use the new software? When we started going down the path and said, you know what, Gradle actually could really work. It was about a year ago that we were really thinking that there's a future with Gradle and learning more about it. Do we want to use the new software model or kind of the existing mechanisms? And we looked into that and ultimately decided maybe existing mechanisms are good for now, just with the amount of change. And also, there's some Ivy support in the new software model that we weren't quite comfortable with. So we also wanted to make it feel very familiar. So some people that use Java, we wanted that same feel of having source sets, dependency declarations, very similar to Java for the other languages. And then we wanted to decide what to put into these DSLs. That was actually the thing that made us feel very good about putting it in here, is we could continually simplify the language that people were using. So here's kind of a high-level diagram of deployment with Gradle. We'd have our source control, Git and perforce, kind of the big ones that we use. And we have our build infrastructure. And if we have Jenkins, we looked at this as, let's have Jenkins as the actor, the UI, and allow users to launch for a release, not necessarily for development, but for release. Use Jenkins to kick off Gradle, have it do a build, be able to publish artifacts from that build into Artifactory, and then launch actually a separate Gradle script on the remote server, SSH over, launch that, and then have it pull all the artifacts down and then do everything with those. So everything, you can't really see the text there, but perform local setup, make the deployment directory, configure it, make any scripts that are going to be launched, load data or code, and create any scheduling, cron jobs, whatever it might be. This was great, because that in some ways it was just we can fire these off on whatever nodes we want. It's almost like Ansible or some other orchestration tool in some ways. The other thing was that we can have Gradle, and we'll talk about this later, but have it be able to pull down only what's needed. So we don't have to blast a whole bunch of things over the wire to every node that needs it. We can have kind of this command script go out, figure out what needs to come down, and download it. So as we started fleshing this out and looked at what we could do to make this Gradleception, that's what Gary's called it. I like that term, Gradleception, Gradle launching Gradle. How could we structure that? And we had we structured it where we could have the build.gradles, any sub-projects we wanted, and then for deployment we would have a separate deployment directory and a build Gradle that's very specific for what happens on the node where we launch and deploy to. And by doing that, we can then pull down all the dependencies, and that made it very extensible. Kind of the high level before we go into what that looked like. The tasks. This is task-wise what it looked like. Your eyes kind of fixed on StageDist there. That was kind of where it would get everything into a directory that was kind of a clean directory with everything that was going to be prepped for sending over. And from that, before it would have our stage directory, we'd have an init script generated that would have everything that Gradle needed in order to connect back to the repository, to pull things down and deploy. There was this GenerateDependenciesScript which contained all the specific dependencies for that project, and so we'd have multiple dependency scripts depending on which project or sub-project. And then once we were ready to send that, we would create this distribution that contained the bare minimum shim that we'd send over, and then we would deploy to whatever server or server set. And so that role was kind of a pluggable piece that it could be whatever servers you wanted to deploy to. And you could also do it local if you wanted to test it. So that was the top branch there. You can do the deploy local. And then once it got over, this is through a remote deployment plugin. Then we had a deployment plugin. Once it got over there on that deployment side, there's a copylibs, which what happened is, and it'll be a bit easier when we look at the code, but the copylibs was the first step to copy everything into the right locations, or copy everything down from the repo. It would install it into the destination directory, and then all was more of a lifecycle task. It was actually the thing that was run when that smaller Gradle instance was launched, that deployed instance. And so kind of the steps there, that prepping of code in StageDist, SCP of a distribution targz to destination server, explode the targz, run the all task, pull the dependencies down from Artifactory and install to install destination. Looking at the code a little bit here, this is for the generate dependencies, so that script. We'd have that script file with everything that was going to be deployed, and we basically would package that up, but have any sub-project that wanted to be a part of what was getting deployed would have to apply the Ivy Publish plugin. And so at the bottom there, the with type Ivy Publication, anything that had that would be automatically included in the deployment. And you could basically, it would create this dependencies. It had a new configuration called deployment, and it would be built with all of those. And then the stage distribution task would basically have it would create that stage directory, and I had to kind of collapse some of these includes up there just to make it so it fit on the slide there. But it was creating the stage directory and filtering out. It would keep like the Gradle W, the Gradle script plugins. It would include the settings and everything from the deployment directories way out there to the right. But it would filter everything else out that wasn't part of this deployment. So all the local stuff would stay there, but everything in the stage dist was ready to go out the door. And it, as part of that, the interesting part I think is over on this next. Further on, so at the bottom here, it continues that it would it would create, so this dependency script would be built, and it would let's see here. That's a project test. Yeah, so what would happen is the deployment configuration would basically be this file collection, and that file collection, once you try to resolve any files from that, that would basically be the indication to now pull that down and put it into the Gradle cache. And so it was a very flexible and I think really robust way to be able to get things from Artifactory as they were needed. If you didn't reference it, it wouldn't get pulled down. And the other thing, and what I liked here, is that when we had the generating the dependency script, something I learned in Gradle is that, like that from generate task, it would do two things. It would both make your this stage dist setup depend on all of those. So back here on the, it would one make that stage dist depend on all these generate dependency scripts, and two, it would also make the inputs the outputs from that previous task all be available for what it was going to run here to put those into the stage directory. So it's kind of a little Gradle shortcut, I guess, from having to do all the input, output, and the depends on. You just use that from. Really like that. And then as far as creating our deploy init when we deploy that or create that init script, it would have certain, this is important because it became sort of a template, and everything that wanted to build in and become something that was deployable would basically have to look at these properties and provide whatever's needed here. And all the inputs were repositories, your destination directory, which is set by an extension, the list of dependencies, which would pretty much compute based on what you were compiling with and what you were building those artifacts, and any plugins that were involved, so that it could have those available in the init script. And then it gave this additional configuration section for just anything that was very custom for that script. And so this allowed additional configuration, whether it was Python, Hive, whatever language, and they could add their own pieces in. And it's probably too small to read there. But general idea is that I think this is where I was, let's see. Oh, yeah, so this is, it's the deploy init script file. You probably can't see it, it's a little bit small there, but it's an init script. We initially had started without doing an init script, but we had just found there were some, eventually to get everything treated the same, whether it was a root or a sub-project, and have the same configuration, the same, everything was consistent. Init script, it seemed like it fell out that init script was the best way to do all this and have it ready from the get-go as sort of an ordering thing as well. And so init script is the first thing that's available. We also found a bug because of that, but it was, and then when we would build that, all the projects here would, they would have, it was sort of starting the init script with everything needed. I think the key was at the bottom there, that additional configurations was just adding in all the additional stuff that's specific to each language. So it's like a template method pattern, if any of you are like familiar with Gang of 4 patterns. It's like a template method pattern, and that very end part is where they can fill in on top of that recipe their specific instructions. And so from there, when creating that init script, it also created these important tasks that we showed earlier, the copy libs that install the destination, and then the all task. And those are, the all task is run, and it just does all of the copy. But you can see actually what copy libs is doing there is that it's referencing that deployment configuration, which then pulls everything down and puts it in the Gradle cache, and then it puts it in to the lib directory. So some important tools in doing this, SSH plugin was extremely useful. It allowed role-based server definition, so that we could have, I only want to deploy to development. And I don't want to let people deploy to prod. They're never going to be able to do that without going through some controlled mechanism. But we can have a dev role. Maybe on top of that, we can have the dev edge or the dev data nodes or wherever it might be. The admins may have more access to a different set of nodes. But we can control these through these roles. We can make it happen in parallel. So we can control that. There was a batch size that we could specify, how many we wanted to do at once. And it allowed different authentication methods. And it was very flexible. We could use private key, private public key. We could use password. And you could use SSH agent as well. So it was very flexible. And we even extended that so that we could have our description of our Hadoop cluster be read in. We could create these targets to deploy. So just when it actually do that deploy to remotes, that very last task there that would deploy to a specific role, this deployment.sh, it's just launching the script here at the bottom and executing it in the background and letting it, it's kicking it off. Inside that script, all it does is just calls that all task once the SSH is in. It's very, very small. So I'll show a demo here. And let's see. OK. Yeah. So I've got this project here. And it hasn't been built yet. So I'm going to deploy local. Here's you can deploy local, make sure it all works. It's using all the Wi-Fi here, so if something breaks, I'm sorry. And I should show, perhaps, that the bottom here, we have this remote deployment extension, and we're giving it the deployment directory. We're giving it the repositories that are going to be used, and that's just being plugged in to this, that template, and what version of the deployment plugin we're using. And then this remote's defining roles here. So I can deploy it to AWS, or AWS Hadoop cluster. I can deploy it to our Cloudera cluster. These are just a couple of simple examples there. Whichever user, identity file, and for instance, using agent or not, depending on what's the method there. And so I did a deploy local. It's going to deploy it to the temp nate apps customer activity hub. I guess I should have showed that it wasn't there before, but there's that the executable directory, and then all the libs just going to be everything that was pulled down from Artifactory and available, all the Hadoop stuff. And so from that location, and I'll talk a little bit about what we're actually, the other thing that it's creating, we'll talk about a little bit later, is just how it's creating these runnable scripts. I don't have to know in this case it's just Jetty, but if it were Hadoop, it would have a whole bunch of jars that I'd be adding in, and it was a pain to always know what was getting added in. So we'd have this script generated and we'd kick it off. In this case, it was just Jetty, and behind the scenes it would call HBase in this case. So we can do a deploy to, let me go back. Where is it? Deploy to cdhdev. And then once we deploy to the dev environment, we can go out there and see that it has the same. Oh, it's kind of interesting to see in here. It's deploying to that role that we have, that dev server 2, and in there it's doing all the tasks to pull from. Let's see. So it uploads everything to our Ivy repo. It then on the destination. Let's see. It has an archive file. It opens that up, and you can see it just has very few files in there, very small. And then once that gets opened, it calls the all task and does everything in between there. You can see I customized this one by doing the create web server task. So very customizable. and going out to that server. You can see you got the same thing out there. And so very, very flexible deployment. Let's go back. I don't have a lot of time where I'd show. OK, let's go back and see a few of the other things we did. OK, so kind of going back here. The Java, as an example, it was doing some extension of that plugin to be able to add the start scripts so that we could have just a single script to be run. And this was an additional task that it created. And so you can see here it has at the bottom that additional configuration is getting the create start script installs being done. Basically, it's linking it to that install the destination and configured that way. And so Python would do some other things. Actually, let me go. Sorry, show a couple of. So just Python, we would have these run scripts, which were the same idea. Python could have scripts that were linked to all the Python libraries they needed, and they didn't need to have any special environment set up or anything. So it really was like a build-out replacement at that point. I was basically calling that the build-out killer because everyone was used to running it, a shell script, and not having to think about the size of that script or the availability of libraries. If it was there, you knew it was going to run, and it felt like a bash script. We'd also have virtual environments. This was more for the analysts, data scientists who wanted to customize with their own packages. And then Hive queries and Oozie code was another plugin, and that would address mostly the analysts that wanted to do these daily, weekly, monthly, quarterly reports. And they could have a way to cleanly put their Hive and Oozie code and have it, version and follow better practices. So some future work that we were looking at, let's see here, is the R, wanting to add R and Spark and have support for that. Oozie DSL, in fact, the author's back there, so that's cool, right? Looking at the Oozie DSL, pretty exciting. See if we can use that to help. Oozie's an XML beast, and see if we can tame that and have more just in the Gradle script itself. Have better scheduling capabilities. Cron does so much, and I say that as we can have some better ways of doing scheduling. So, and then since I'm, I only consider myself a Gradle person for about a year. We've used it longer, but I didn't really understand it much until maybe a year ago. So I can still kind of say silly things like this, but undeploy, like that would be kind of cool to have. Like we have people that deploy something, and then at some point, especially like when they're experimenting, it's not going to stick around forever. I don't want to know, do I have to support that or not? And there's ways to keep track of that, but if anybody's ever done anything like an undeploy, come talk to me. That'd be interesting. Where it's, probably going to be something like a uninstall script or something, but make sure that you cleans up whatever you put out there, and unschedule is probably the big thing. You just don't want to have stuff running that nobody cares about. And I can show you a little bit how much time we've got left here. We got 10 minutes? Okay. I'll just briefly show you just the Python. How it, let's see, this is Hive here. So yeah, Python, just showing how it could additionally customize. That's not very big, is it? How do we zoom? I'm not a Mac expert here. If we try to make that look bigger. It doesn't want to look any bigger here. Anyway, it's, yeah, I'm not sure how to get that to size up. But what is it?
Has to be an editor option.
Oh, an editor option? Yeah, that's what I would think.
And probably if you change just the background.
Duplicate, nah, I'm not seeing the bigger option.
Try presentation mode under view.
Oh, under view? Oh, enter presentation mode. Oh yeah, cool, thanks. So, yeah, we've got, thank you. We're adding additional stuff for Python here, like for generating those entry points for those run scripts. In some cases, we're using easy install for the run script side of things. We're using pip for the virtual environment side. And it's, in this case, we're just saying, okay, we've got a Python extension that we can tell it where we're putting all of our site packages. We've got the additional, we can just start everything out with the configurations already set to deployment for those entry points, virtual envs. Very similar. Make sure it's got that deployment configuration and knowing where to install the virtual env. So this ended up, we had a kind of an iteration before where it wasn't quite as customizable, and so they worked differently. Java was very different from Python, and they were workable, but it just meant like we didn't really need to use the deployment tooling, and we wanted to be able to, again, it would have been the same problem to some extent where we were just diverging in how we deployed. So we kind of brought that together, and I liked how it turned out. Yeah, so going back, now if I can figure out how to exit the presenter mode here. What's the secret to that? Who told me how to get in there? How do you get out of it? Oh, okay.
I do Command Tab.
Oh yeah, hey, that should do it, right? Ah, very good. Okay, thanks. So just in the conclusions here, DSLs for build scripts are really awesome. I like it. I came from the Scons. As I said, Scons is this Python build tool, and I really like that you could introspect and see, as I'm trying to build, I could go in and see what pieces of the object model are available. That was really nice. But in some ways, DSLs are nicer. And with the Kotlin support they're coming out with, I'm excited to see how that can help supplement and make more introspection of build scripts. I think it'll be pretty good. Again, Gradle object model can be difficult to navigate at times. As a newer user, I found that often to be the case. But love having a single investment for all the build goodness. And importantly, we found out Ethan likes sushi. So, so that's everything I've got. Any questions? Do you have any additional comments, Gary? Gary's kind of the man here. He's
I would say that, just to kind of point out too, the value of kind of using Gradle as the deployment mechanism on the server side. So, one of the things that you're showing there is this ability to kind of wrap up this minimal set of scripts, which is very small and lightweight. You push it out to the servers that you're deploying onto. Is that if you imagine kind of the standard approach to deployment is I create a big bundle that has everything that I have in it. I push it out to a server and then I unbundle that there. On the other hand, you create this minimal set of scripts, you push it out there, and then it's going to take advantage of the Gradle cache. So it's not downloading everything on every deployment. Let's say you have 20 different jar files that are associated with the deployment, but only one of those actually changes. Well, he's going to download just that one, and that makes a ton of sense when you're talking about having a big cluster of maybe 100 servers, where you're minimizing the amount of work that's actually being done on each server. And so I think that's kind of a big value of using Gradle on that deployment side of things. So.
Yeah, I didn't show, but you can run it in continuous mode, and you can start coding it. It'll just take whatever artifacts need to be updated, and it'll push them out there, and you can basically have a continuous development cycle with your cluster. It's kind of interesting. In dev, maybe that's okay. And we still put in I have this fail-safe mentality, and so even though it was great to have like Artifactory and have some of these other tools that could help out, I still made sure we had like what happens if everything sort of like craps the bed? What do we do to get stuff out there? You know, what if Jenkins doesn't work? What if Artifactory doesn't work? So we have an option to package everything and send it all out in a huge bundle, which wouldn't be ideal, but you could do that. If Jenkins is down, this is headless. You can basically kick this off from the command line as you're seeing, but there's also a way to go through Jenkins, which is a standard release mechanism. So, thank you.